My name is Abhishek. Welcome to my YouTube channel. This is a playlist for interview questions and problem solving where we will be improving our core programming skills by taking problem statements and solving it one by one. So in the part A, we have seen how to approach this problem statement using arrays as the data structures. In the part B, let's approach the same problem statement using linked list as the data structure. And also compare what is the time complexity and space complexity as compared to arrays. And let's get started. So this is the problem statement. Given an unsorted list L of n elements with values or records L0 to Ln-1 and target value T, find the target value T in the list. So we will be having an unsorted list of elements. We have to find a target element and give the position of this target element. So let's see how to approach this problem using linked list. Now let's see how we can apply the same linear search using the second approach, that is using the data structure as linked list. So in arrays, the elements are stored in a sequential memory location, but in linked list, it need not be sequential. So wherever the slot for the node is available in the memory location, it will be stored in that location. So a linked list will consist of series of nodes. So this is one node, second node, third node, fourth node, and fifth node. So it will contain a series of nodes, and inside each node we can store data along with the reference to the next data that is stored, or the next node, right? So every linked list will have a pointer head which will point to the starting of the linked list, and each node will be having two parts. One is data and reference. So this reference will store the address of the element 6. So similarly for the second node, we will have a data part. Inside the data part 6 is stored. In the reference part, the address of the next element 10 is stored. So this will continue to be a sequential. Using these pointers, right, we can access or iterate sequentially through the elements. So once the end is approached, the end of the list is approached, the reference will be null. There will be no reference to the next element. So this null can say the list has ended and you have this is the end of the list. So here similarly, as we did in the arrays, we have to search for the element 2, which is target, using the linked list as data structure. So let's see the code snippet and try to trace one example. So this is a function for the linked list. As I said, head will point to the beginning of the linked list. We will check if it is null. So why we are checking? We are checking it has the pointer reached to the null or end of the list. So we will iterate until the size of the list and try to check the data, which is this part. So we will check for the data if it is equal to target. If it is equal, we will return the address. So that is the address of the target element in the list. So if it is not found, right? So if this condition doesn't match, so we have to point to the next element, which is 6. So to do that, we can update the head, or we can use another variable current, something like that. It is not recommended to update head because it has to. It's defined that it has to point to the beginning of the linked list. So we can update the head here using this head of next. Next is the reference. Next reference to the next node. So we can again go back to the loop. It will check for the data. If it is equal to target, it will return the address of the node. Otherwise, we will go to the next element. So this loop will iterate until the size of the array is reached. So if the size of the array is exceeded, so we have to return the value or search is unsuccessful. So we can see in the definition of the linked list, so the last element will be null. So after iterating through it, it will return null. So let's take an example and try to trace the program that we have written. So this is an example. We have a linked list in which the elements are stored and the target value is 2. We have to find for 2. As usual, the head is pointing to the beginning of the linked list. So let's see. Is the head is null? It is not equal to null. It is pointing to some address. The head of data. Head of data is 8. Is 8 is equal to target 2? Is 8 is equal to 2? False. So this if block will not be executed. Now it is not equal, so we have to point to the next element. To do that, we will do head is equal to head of next. So now the head will point to here. So we can see for the next address is 6, so the head is pointing to 6. So his head of data 6 is equal to 2, false. As it is false, we will update the head. Now head will move to here. Is head of data is equal to 10? Is 10 is equal to 2? False. Now it will not execute the if block. We have to point to the next element. Now head is equal to head of data. Head is equal to head of data is 2. Is this value of node 2 is equal to target value that we are searching for 2 are equal. So yes, this condition is true. This if statement will become true at this stage. Now we have to return the address of this node, right? So this will return the address head that is pointing to the target value. So this is for search is successful. So let's say we have to search for the element 15, which is not there in the linked list. So at that stage, it will iterate from here to here till the end. The head will point to the null value. If the search is unsuccessful, it will return the null value. So this is an example of tracing the code snippet that we have written. Now let's get into the implementation part. So for implementation, we have to define two classes, one for node and second for linked list. So let's define two classes, node and linked list. Class node. Now we have to create a node with data and reference to next element. So we have to create a node like this. So where we can store the data and reference to the next element. So to do that, we will define a constructor in it. Whenever this class is called, it will automatically create a node. Self data that we want to store the data. Self.data is equal to data. Self.next is equal to none. So this will create a node and store the data, and reference to the next element is none. So this will create a single node and return. Now let's define a class linked list. So to define a class linked list, let's initialize the constructor whenever it is called. So when it's called, we need to have a pointer, right? So whenever a new linked list is created, we need to have a pointer head, which is pointing to the beginning of the linked list. Now we have not created any node. Let's keep it to none. So after creating a node, we need to insert, right? To create a node, we need to insert and update the linked list. So let's insert. Whenever we get a new data, let's create a node and construct the linked list. So when we get a new data, so this function has arguments new data, which is an integer value stored in data part of the node, right? So this function will create a node and update the head and returns none. So it returns none. So let's create a new node. To create a new node, we need to call this class, right, along with the new data that we have. So let's call the class, let's create an object of the class node with the new data. So this will create this node and return the node reference to new node object, new node variable that we have here. So the new node dot next should point to self.head, and self.head is equal to new node. So here we are creating a node and pointing the current head to the new node, and we are updating the next to the next node. So we are basically inserting it to the beginning of the array, like beginning of the linked list. So after it, we have to return, which will return none. So after creating this pointer, the control will be returned to the wherever it is being called. So let's apply a search function where we have to search for a target value in the linked list. So let's define a docstring. So we have args target, which is an integer target value that has to be searched in the linked list. So as I said, we should not use the head pointer. I'll be creating a current variable, so which will be used for updating for the next reference. So initially the head will be at the beginning, so we should start from there. So we will apply the while loop as I explained in the code snippet. So is current is not equal to none. So if current is equal to none, it means that we have reached the end of the list. We have to terminate this while loop. So if current dot data, if current of data is equal to target, is the current element data matching with the target element? If it is matching, we have to return current pointer. Otherwise, we have to update, right? So current is equal to current dot next. We have to update the current pointer to the next element. So if it has reached end, we will encounter a null value at the end of the node, right? So we have to return none, which means the search is unsuccessful. We have searched for the entire list, we have not found the target value. So this function will return node address, which is of type node, class node, right? Returns the reference to target element found in the list. So this function will return the target element reference that you are searching for. So we have implemented classes and the search functions. So it's time to write some driving script to get started with running these functions. So let's create a SSL object, which is single linked list object. We'll create linked list class. So this class object we are creating. So we have to insert values, right? So we have to use SSL object dot insert. We are calling this function and inserting these values. So let's insert these values. 8, 6, 10, 2, 4. So we have these 5 elements inserted to the linked list. Now we have to search for the element. So let's write a driving script. Do you want to perform linear search, which is yes or no? If it is equal to yes, so we will go inside the while loop and try to get the target that we are searching for from the user itself. So input, enter the target element to search. So we will get a reference object. Let's store it in the variable result, singly linked list object that we have created, dot search function. So we are searching for a target element given by the user. If result is equal to none, so which is pointing to the null value, if it is equal to none, we will print search is unsuccessful, target was not found in the linked list. So if it has searched the entire list and not found the target value, we have to print this statement. Otherwise, we can say the search is successful. So we have found the result. It is stored in the result. So let's print the data. The result is a node, and inside the node we have the data found in linked list. So we have to print this statement. So let's apply some escape sequence so that the output looks neat in the console. Yeah. So let's execute this. So we have defined the class and driving function. Yes, I want to search for the element. So the element that I want to search, let's say it has 2. So we have to see, okay, this function is print. It's a typo error. Yes. 4 I want to search. You can see the search is successful. 4 is found in the linked list. So let's search for an element which is not there in this list. So let's search for 26, which is not there in the list. Yes, I want to search. The element I want to search is 26. You can see the search is unsuccessful. 26 is not found in the list. So we have applied the linear search using these classes and these functions inside the class. So let's see the time complexity of the linear search that we applied using the linked list. So as we see the number of iterations that we have to perform here, right? So similar to the arrays, the number of iterations, if it is found in the first position itself, the time complexity is a smaller of 1, which is the best case. And the worst case, we have to search for the entire list and end up not getting the match found for the target value. So in that case, we have to iterate to n plus 1 elements. Similarly, the average case is n plus 2 divided by 2. So if we solve for this equation, we will get the time complexity as big O of n. And the space complexity, so if we see this node, right, so we are along with the data, we are using another variable for the reference to store the next address. So for every node, we are using this extra space, which is required to store the next reference to the next element. So that is why the space complexity, if we are storing n elements, we require n addresses to keep track of the reference of next element. So that is why the space complexity of linear search using linked list is big O of n. Whereas using the arrays, it is big O of 1. We are not using any extra space in arrays. We have seen how to approach the problem statement using arrays and linked list. When we compare both the methods, right, the time complexity remains the same, big O of n, but when it comes to space complexity, arrays require big O of 1 and linked list require big O of n. So we require extra space for storing the reference elements in linked list. So let's solve another problem statement in the next session. I'll share the link to this notebook in the description. Until then, keep learning, keep teaching, and keep sharing. Thank you. Let's meet in the next tutorial. Please like, share, and subscribe, and press the bell icon to get a notification. Thank you.